In this video, we're going to take a look at the technologies that go behind service-oriented architecture. One thing I want to stress, and one of the things that a lot of people struggle with when they're trying to understand what SOA is that SOA isn't a thing. It's basically a set of standards and a set of technologies that are all kind of clumped together to make business development easier. So even when you buy the SOA suite from Oracle, which is a managed server that goes along with the Oracle WebLogic server, it's not something that you just put in place and then you put an application into it and you say, make this SOA. That's not the way it works. You have to actually design your applications in the SOA framework and the SOA architecture. That's why it's so important to have kind of these background videos just to understand what SOA is. What the SOA server actually does is it enables all the different technologies out there and the management of all those different technologies in kind of a graphical form, so that when you are ready to deploy your SOA type applications, you can do so relatively easily. You can monitor them relatively easily. You can set up applications that use those technologies. Those applications are commonly referred to as composite applications. That's what the SOA suite is really doing for you. It's not going to turn an existing application into a SOA application just by deploying it to the SOA suite managed server that goes along with the WebLogic server. It doesn't quite work that way. So that's why it's important to understand all of those different pieces. In the previous video on SOA, we talked about architecture and how architecture has evolved over the years, and why we have this kind of new need for a different type of architecture that's really aligned with business processes. This video is really going to focus on the different technologies that make up SOA, and there's so many different technologies that really make up all the different SOA pieces. I can't talk about all of them in a 10 to 15 minute video, so I'm going to hit on the big ones here, and hopefully that'll all make sense. In the third video, we're going to look at the business motivations for SOA and how these different technologies make business development and the monitoring of how your business is working a heck of a lot easier. But in this one, we're just going to focus on the different technologies out there. One of the core technologies that goes along with just about all SOA is something called a web service. And a web service is something you can think of as kind of a black box. It's not exactly that, but you can think of it that way. And for those of you who are not familiar with the term, a black box is something where there's input, something happens here, there's business logic, there's some kind of magic that happens here, and then there's output. And in really large systems, like an enterprise system, you have tons of different modules, tons of different sets of code for accounts payable, accounts receivable, warehousing, purchase orders, human resources, all of these different things. And these systems have become so large and so complex, it can be a real challenge to go in there and say, hey, I want to make a change. If I could take the specific functionality that's in each one of those pieces, break it into a web service, this gives me a whole bunch of advantages. And again, in the third video, we'll talk about all the different business advantages that are out there. But from a developer standpoint, imagine I had something like a credit check. If I have a really large organization that does accounts receivable, accounts payable, purchase orders, warehousing, inventory, we sell services, all of these different things that are out there, it could be a real challenge. You probably have different sets of code to do different types of credit checks, right? You might have a credit check for an individual consumer. You might have one for a vendor. You might have one for, I'm trying to think some other places that you would need to do a credit check. Different organizations in terms of, transferring warehouse inventory numbers and all that sort of thing. You probably have a whole bunch of different places inside your organization where you do the different credit checks. It's really hard to maintain that at a business level, right? You want to make different rule changes to the credit checks. You have to go all of these different places. You have to test them in all of these different places. They could be on different systems all over the place, different programming languages, different operating systems. Could be within like the Oracle e-business suite or SAP or some other large enterprise software tool. So if I have a really large organization, this could be a real challenge for me. If I could consolidate all of the code that goes along with credit checks in one place and turn that into a web service that then can be called by any other application that's out there, there's a lot of real nice advantages to that. Again, third video, business motivators for SOA. We'll talk about that some more. But you can think of a web service as kind of a black box. It's a discrete business function that's going to have some kind of input, produce some kind of output, and it's going to be exposable over the web. Once I have this web service created, how do I know about it? How do other developers and other programs make use of this web service. Well, there's something called a WSDL. And WSDL stands for Web Services Description Language. And it's nothing more than an XML file that describes the web service. It's an XML file that says, okay, here's the web service, here's where it is, here's what the types of fields that you can expect that the web service is expecting as input, here's what it's going to produce as output. There's a couple of other really cool things in there also, but the WSDL file basically describes the web service. And again, it's all in XML. So the next question is, okay, what in the world is XML? Again, web services, WSDLs, and XML are not specifically SOA technologies. WSDLs, web services, exist outside of SOA environments. XML exists all over the web. But these are all of the things that SOA kind of brings together in the philosophy of breaking down applications into these small pieces and then putting them back together under what are called composite applications. So XML stands for extensible. So it's extensible markup language. And if you're familiar with HTML at all, it's very similar to that. The main difference is HTML has predefined tags. P for paragraph, B for bold. It has all of these predefined tags. XML, you can define your own tags. So you can have tags that describe data. You can have tags that describe metadata of data. You can have, these incredibly complex structures within XML. But that's kind of the standard language for SOA and the different pieces that are going to use a lot of these technologies, like WSDL. WSDL is nothing more than an XML file that describes what a web service looks like. So when you have a programming language that wants to call a web service, it looks at the WSDL, it figures out how to call all of that piece of information, and then you can write code based on that. Almost all modern programming languages allow you to create web services out of the box. The latest versions of Java and JDeveloper make it real easy to say, okay, I have this little piece of code inside my application. I want to isolate that, turn it into a web service. In JDeveloper, you can do it with like 2 lines of code. It's real nice, a real easy way to do that. Same thing with the WSDL. Most modern programming languages, if you provide the WSDL information, it'll say, oh, okay, I know what the web service looks like, and it can construct a form for you to say, okay, these are the inputs I'm going to need, here's the credit check code that I'm going to call, here's the output I'm expecting, and here's how I'm going to display it back on the screen. Almost all modern programming languages will automate a lot of these steps for you, so you don't have to go through them manually. Once I have all of these web services kind of isolated, let's say I have a whole bunch of these different little black boxes together, how do I kind of link them all together? Based on the output of this credit check, I might want to go to, some kind of form where if I fail, I want to send an email and I want to display something on the screen. If I succeed, I have to go to some next step in the process. I've passed the credit check. Now I'm going to, go to my inventory module and allocate inventory for this vendor, or, whatever it is we're talking about. How do we kind of link these different black boxes together? Well, there's something out there called BPEL. And BPEL stands for Business Process Execution Language. And again, if you use JDeveloper, it's really nice because JDeveloper has this graphical tool that allows you to kind of have this kind of graphical representation of how you want the flow to go, and it'll generate all the code for you automatically. That basically says, okay, based on the output, have a decision point here. If the decision point comes back with a 0 or a fail, do this. If it comes back with a 1 or a pass, go and to call this other module or this other program or this other web service. So BPEL is another technology that allows us to kind of link web services together. There's another tool that comes part of the server-oriented architecture, not something called an enterprise service bus. If you're working with Oracle, the Oracle version of the ESB is something called OSB, the Oracle Service Bus. And the Oracle Service Bus is really a way of managing all of the different messages that go back and forth between the different web services, between the different systems that you're integrating through SOA. And ESB, or the Oracle Service Bus, has a whole bunch of different functions. And the prime duties of an enterprise service bus is to monitor and route messages. And messages could be anything that's coming in or out of these different web services or other code that's there. We want to route all of these different pieces together. We want to resolve contention between web services. We want to be able to version our web services, right? If I create this credit check and I want to be able to enhance it, I want to keep enhancing it over and over again, I may add new input parameters. I may then add new output parameters. What about existing programs? Existing programs that are using this credit check web service, now they're not going to function because there's different inputs, there's different outputs. I'm not going to get the information that I need. I don't want to break all the existing programs out there. An ESB or an OSB allows you to have versioning of web services that are out there, where an ESB will be smart enough to say, okay, if I'm calling credit check and I'm only passing 2 input parameters and I'm expecting 1 output parameter back, I'm probably looking at version 1 of the credit check web service. Version 2 has 6 inputs and 3 outputs. So the ESB can handle those different types of calls without breaking the existing web services that are out there as you actually enhance them. It also caters to commonly needed common services like event handling, event choreography, data transformation, mapping, message event queuing and sequencing, security, exception handling. So the ESB handles a lot of different stuff. You can manipulate data, transform data that goes in or out of a particular web service depending on the type of application that's calling it. You can queue events, you can sequence different events that says, every time somebody goes in and does a credit check, I want this other thing to happen automatically. I can handle security at this level. Putting an ESB in place really gives you a lot of flexibility. It's easier to make changes as the requirements change in these complex systems. It also scales from something called a point-to-point solution to an enterprise-wide deployment. Again, if we have this credit check and we've hard-coded the values, we can't make any changes to it without breaking any other pieces that are out there. With an ESB, we can go ahead and make changes to the credit check, have different versions out there, and not break the existing programs. There's no central rules engine, there's no central broker, and it's really easy to implement patching. You can implement patching with 0 downtime. The enterprise becomes what's called refactorable, which allows you to go in there and say, okay, I want to make all of these changes. If I have implemented an enterprise service bus, I can make a lot of these changes underneath the scenes without having to bring down my existing environment. For those environments that are 24/7, that's obviously something that's really essential. So this doesn't talk about all the different technologies that are out there, but this kind of hits on the big ones that go along with the service-oriented architecture. Like I said, in the third video, we're going to take a look at the business drivers and how each one of these makes it a lot easier for businesses to implement SOA and gain some real benefits from it in a real short period of time.